All right, we're live. It's March the 10th, another late night LeetCode. I've been writing the whole day. My God, my brain is already mushy, but we're not going to give up and still going to attack it. I mean, I have submitted all my writings today, so this should be a little bit entertainment for my brain. All right, before we start, always, look at here. Oh, replied again. I'm just gonna take a look, but I don't really think we are going to make any more comments. This has been dragged on for way too long. But we do not know which element we want to remove, so it takes undefined, and we want to remove an O1 to remove it for linked list. O1 define and another O1 to remove both time complexity. Oh, that's what he meant. Yeah, it is. It is faster. Okay, I can reply to this. Yes, that's what I mean by faster. On plus O1 faster, and then On plus On. Although theoretically, although asymptotic, how do you spell it? Oh my goodness. No, it's not asymptotic. Yeah, that's it. Yep. Although, technically, they are the same. Alright, this is the last one I'm going to respond. And let's take a look at what we have today. Integer to Romans. Oh, we did this. We did this already. Yeah, that is remember we had a Roman to integer, which is an easy question, so we decided to do this integer to Roman as well. And I remember my solution was a bad one. I mean, it's not bad, it's just not as efficient. And we have a better, I think we implemented a better solution. I don't remember what we do. All right, so I think the ideal is to remove, come on, man. Come on, we know. We kind of know. So okay, what I remember from this is each number we need to remove. We need to know how many of the biggest we need to remove. That is the idea. How many of the biggest value we need to remove. And we remove that. And then we record that as well. So how do we know how many of the biggest we need to remove? Well, I think we create a, oh my dear God, I forgot about this. Well, I think we create a dictionary for all the values, right? And then we're gonna start removing from the biggest. And then once we remove the biggest, no, I feel like there's a better solution than this. What is the solution? So give a number, right? We remove the largest. All right, and then what? We remove the largest, and if we cannot remove the largest, we remove. Probably have to draw back to what we did before, but I remember, I clearly remember the best solution. that we actually saw, and we're like, oh wow, this is such a good solution. But what did that solution do? What's different from what we do? I mean, given a number, right? We need to know how to express it. So we say we are going to give a number, right? Give a number. We can attack from the smaller side. Can we attack from the smaller side? Individual value, yes, we can attack it. Like individual value 1 to 8, right? 9, and then yes, that we can attack. And then after we attack it, we attack the second value, which is the 90 value, right? So we can attack that because we have an idea of how that shall be. And then after we attack that, we attack the next one, we attack the next one, and we're done. So we can attack from right to left. It's possible. So what we need is, so for 1994, right? So 4, right? So 4, what do we need is a V, and we need to put I in front of it, right? How do we generalize that? I remember a very smart idea that we saw eventually, but I forgot how it does. It adds something like to the end, and then as we go through each letter, we are able to what is the idea that's very smart? We actually implemented a smart idea. I can't remember. I mean, we can do it like the stupid way, right? The very stupid way. We set up basically a dictionary to record every single one, right? So for one, shouldn't set like every single one. So we have the special cases, and then for the smaller ones, like for 3, for 2, when we see that, we just add the 3 eyes, right? And so for any value, right? 4, we can just add 1 and add a V. Nah, I don't remember. We probably have to do it the stupid way. There's no way. Yeah, we have to do it in a stupid. And how are you going? If we go from right to left, yeah, I remember. If you go from right to left, the problem is it's hard to put it in the in order, right? So you have 4, so you put IV in it, and then what? You have to add in front of it, and I think we have a problem with that. So that's why we have to go from front to back. Now from front to back, it is possible. It is not possible. It is possible. So let me think. As we move, so from front to back, we know the value. How do we know the value? How do we know the value? Well, we know because we know the total number that we can do, the total number, and we get the first one times that, so we know the value is 1000, and then we can apply 1000, so we handle 1000, and 2000 would just be mm, 3000 would be mmm, and then that's it, because the maximum is 3999. So we'll get that for the 1000, and then next one, right? Go. It's 900, and 900 is a special case. We take care of that. So we have all these. I have 900 of 49, 40, 90, 400, 900, right? And so for anyone that is not in this list, that means it can be formed by doing the arithmetic, right? So we say if it's smaller than, no, it's all addition. It's all addition. It's all addition. It's all like I or x by itself. Or so how do we code that? So like if we have 800, right? 800. So for 800, how do we know we're gonna go for 500? How do we know that we go for 500? Well, we know that because we can just loop through and find the one that is this. I find it, and then the remainder is 300, right? So the 300, I'm gonna go find it again. We find that, and we add that. Yeah, that's possible. Yeah, that's possible. We can just iterate through, which is fine. I mean, which is fine because it's a very small space. We're gonna let it iterate through. We find it, and then we can do it. And the only thing 49, and then say we have 300, right? 300, we find this, and if we have 80 or 70, we go this. So we put this one first, and then 20, we go there. Yeah, I think it's, yeah, this is a way, right? This is a way we can definitely solve it that way, but man, I cannot for the life of me remember and recall the good solutions that we encounter. Like the really smart ones. I remember there's a really smart one. I don't remember at all, which is such a shame. Anyway, we are going just to use our stupid idea to solve this, because hey, even if it's stupid, as long as it gets its job done, we are happy. All right, stupid, let's go. Stupid idea. And we're gonna just iterate through instead of doing binary search or whatnot. This is not really necessary. Binary search. I just realized it's actually not too bad an idea. All right. I mean, but the search space is so small, right? The search space is so small, so I think it's fine. So we're gonna say the symbols equals just the dictionary. So the key is going to be 1, is going to be I. Oh man, I have to type everything. 5 is going to be V. 10 is going to be X. 50 is going to be, no, 50, these are all, no, this is important, we have to use this. 50 is going to be L. Next one is C, no, 100, what the hell, C. Then 500 is D. Finally, 1000 is M. Now, in addition to this, we're going to also add 4 is IV. These are special case, right? And then 9, which is an IX, right? 9 is IX, the IX. Next one is 40. Right, 40 is XL, and 90 is XC. Then we have 400, which is CD, and 900, which is DM, not DM, CM. Right, so we have the symbols. Now what we need to do is, we have this value, I'm going to turn this into a, so we're going to turn this, so we're going to say, what should I say, the power is going to equal to len, strnum equals str, so turn into a number, so power is going to be strnum minus 1, right? And then we're going to say for d, just for d in strnum, current value should be d, should be int d times 10 to the power, right? And then we're going to say, and I also have a result. It's empty string. I'm going to say for key in symbols dot keys. No, this is going to be, we're going to have another one. We're going to say KeyList equals list symbols dot keys. Yep. I want to say for I, k in KeyList. Then we can actually use binary search. Then we can just make it from bisect, import bisect. I think we can do left, right? If what do we want? If like we have a value, say it's 300, we want to go left. So when we have it, we need to go left, and bisect will have the left. Oh, actually right. I have to do right. So we're gonna say index equals bisect right. What is this? KeyList and our current val. So, and then after we do that, we know exactly the ones that we want. So we know the key, right? So after we know the key, so we say res plus equals, we know the key, we know the key. Oh wait, actually it's not there yet. So we know the key that's currently, so we actually, yes, this actually should be a, so it's be while val. So we get this, right, and then res plus equal to a current index. So it's going to be symbols, symbols what? KeyList index, right? Because let's say we have 800, right? 800 coming in, and 800 the first thing it finds the index because it's bisect right, right? So it's going to insert here. Try to insert here. 800 is inserted here. So when we actually have to minus 1. And if it's 900, it's going to insert here, and minus 1 will be 900. So it's going to insert, it's going to find this D, and then we add D, and then val minus equal KeyList index, right? So we minus 500, now it becomes 300. So 300 coming in, it's going to find here, so we're going to add a C, add another C, add another C, all right? And after that, the val becomes 0, and then come out, and then we look for the next one. And as we do, power needs to also -1. And then we're going to return the rest at the end. Okay, let's give it a shot. Man, this is so ugly. I remember there are very good, very good solutions, but I just don't remember. I mean, we don't even know if this is correct, so we have to test. Now, these are good test cases. I want 58 is a good test case. 58 is a good test case. And 1994 is a good test case. MCM, XCIV, right? So it's gonna be num and int to Roman num. Let's see. Okay, we pass everything, and I think we just submit it. Pass all these. Good. Let's do like just 1, 2, 3, 4. Right. Let's give it a shot. Yeah, it's correct. How about 1? Last test case. Pass. Yeah. Let's go. Yep, we got this. But still, I feel like there are better ways to do this. Anyway, let's check. Let's take a look. What's our runtime? Oh, terrible. Terrible. My goodness, we have terrible runtime. I think this is probably the same solution we had last time. That is the very first one. Unbelievable. Can't like this definitely costs time, I think, to the power and stuff. This is I don't know, what's the runtime for this? This is not the best solution. I knew it. I knew it because I have done this problem before, and the best solution does not look like this. This is just a solution. It starts from the left of the number and going to the right. Each time we take out how do we say that? For instance, given a number A, B, C, D, we first look at A times 1000 and see how that number can be represented. Then we move on to B times 100, C times 10, and eventually D. For each value, we look up in the key list to find the closest value that is smaller, closest key that is smaller than the value. We know for sure that the biggest key, that is smaller than the value must be used. So we repeatedly remove the key from the value, repeatedly add the Roman symbol represented by the key and remove the key from the value until the value becomes 0. I don't know. I don't know. I don't know. I don't want to calculate the runtime of this. I mean, this is all. This is like, what? I mean, it's all one like, in total, so it doesn't really matter. Anyway, so this one will get 56 milliseconds. Since the input space is very small, alright, let's see. So this is O(n), that's the length of the number. And let's just consider these are all ones, and then this one, what's this one? So each value at most is all one, because each one at most we do it like it's 4 times. The most is 4 times, like an 8, right? 8 we do it 4 times, and that's it. So it's O(n). So we're gonna say O(n). I'm gonna say O(n). 56 milliseconds with a 39% ranking. My God, it's so bad. I am not happy at all. I mean, we did this before. Can't believe it. You know, we weren't able to come up with a better solution. I'll probably just go to my. I don't even know where to go, because we had this one before. Unbelievable. Unbelievably dumb. Look at this. We did it many, many times. Actually, it's about like a few weeks ago. I actually have a better runtime here. I have 44 milliseconds. Look at this. Look at this. We have units, we have symbols. Yeah, let's actually I know where to look. We have, let me see, where do we save it? Wait, which question is this? This is number 12. Yeah, find it. There we go. All right, I think our first idea is the same. Oh, there's a stack. Oof. Ooh, what the heck? Ooh. No. I think even okay. I think we have improvements. All right. So the ideal is I don't want to. Did I just go from right to left? I have a stack. Yeah, we didn't go from right to left, and then we need to like determine. We need to determine. Oh man, this is. Oh, it's a DP solution. As more numbers are fed to the algorithm. The trailing value. We take 4, 90, yeah. If it is in data already. Oh, we even created data. Oh wow, I know. Well, this is complicated what I was trying to do back then. Okay, if not we assemble it by subtracting the smallest unit proportional to the trailing number itself. For instance, given 8, it will be subtracted by 1 as the smallest unit. Given 80, it will be subtracted by 10. How do I know that? Subtract from the current unit. Oh, so we keep track on the tens. Subtract, and then we're gonna append. Subtract and append, subtract, append. Okay. I mean, both are stupid, right? Both are stupid method, but I actually like this better. I mean, it's shorter, it's neater, right? It's more neat. and it relies on some string number conversion, which is fine. I mean, which is all fine. Yeah, we use bisect. All right, so let's take a look. Much cleaner. We subtract from the biggest to smallest. Yeah, that's what we're trying to do, right? We subtract from the biggest to smallest. So I have I. Oh, holy moly! Yeah, exactly. Yeah, I do remember. Just to subtract. Yes, we subtract from the biggest. We subtract it. Every time we subtract, we add it to it. We add it to it. Okay, how about 900 subtract? So we keep moving forward. Yeah, this thing keeps moving forward. Huh. If the number is smaller, then we need to move forward. Oh yeah. All right, let's see. We see how this is. We see how this is. Simple solution. Is this one the subtracting? Oh, I remember this one. All right, we know how this is. Do we implement it again? I mean, we did implement it last time, but that didn't really help us to memorize it. I don't know why I didn't think of, because this one definitely shall. We shall. Oh, it's the same idea as this one, but implemented in much nicer way, right? If you think about it, it's the same thing. When we use bisect to find it, and then we kind of, iterate through. So what they do is instead of finding a bisect, we just say by default, we're gonna start from the biggest, and then we're gonna move on. Yeah, let's implement this again. This is like the second time implementing the same thing, but I probably will leave the dictionary as is. I'll leave the dictionary as is because it's fine, right? And then we're gonna have the key list, right? And I'm gonna say, basically we say for key in key list, right? If num is larger than equal than key, then rest plus equals symbols key, and num minus equals key. And do we go up? No. Oh, that's why we have to use I. Because if this, yeah, we have to use I. For I in range len key list. Oh wait, but that key list. No. I don't want to change it, but it seems to be a little bit difficult. All right, we're gonna do reversed. Oh man, this just seems so nasty. So nasty. I have to reverse. Oh man, I just don't want to redo this again. That's all. That's all it is. Oh, goodness. All right. Does this even give us the right thing? I actually don't know. That's a good question. I don't know. We did reverse in the past, and reverse does not give you a. I don't think it gives you. Yeah, it gives you iterator, so you cannot index it. So this is like useless. So what we're gonna do is we're gonna call this, and then we're gonna call this the same, right? And land this, and then we say if number is larger than key list I, Then, oh, actually, no. Actually, no. Actually, it's while num, I think. While num, and let me say I is equals 0, right? And if it's larger, then it's going to be key list I, and num going to minus key list I. All right. Else, if it's smaller, if the number is smaller, then we have to move the key forward. And while num and I smaller than len key list, just to check, just in case. All right. And then we run solution 2. Oh, we did not return. Return the rest. Yeah, pass as well. Yeah, that's the standard solution. So this is the official good solution. In a sense, solution 1 is actually, I'll say, is actually in the ballpark of the solution, but we use bisect. I mean, if you use bisect, hold on. The idea isn't like you use bisect, you find one, and then you should do. I just use too many bisects. It's like, yeah, you use bisect too many times. But we use bisect to locate which key to use for the current value. This is not necessary because it is guaranteed the key to use will always go from the largest to the smallest. So we only need to keep a pointer going from the largest key downwards and fit as many and remove as many keys as possible for each value encountered. Alright, this is the second time. Actually, this is the third time I have done this problem. I sincerely hope that I can remember this solution. I mean, the key to remember this solution is just to understand that the keys, what I mean by keys, or these values are keys. The keys will only decrease, right? If we start the key at here, and then if it doesn't fit, we just keep moving and always move in one direction. There's no change. So we can just keep a pointer to the key and always going to the smaller side. And every time we encounter one, we just remove as many of it as possible from the current value until we cannot remove any more, and then we move on to the next one. And that's it. That's all it is to it. I feel very stupid about this. Unbelievable. Yeah, this is really good. I'm gonna submit it. It's fine. That's fine. All right. That's it. That's it for today. It's not a good day for me. Yeah, I couldn't remember the good solution that we had. But that said, we still were able to solve this problem. I mean, using a slightly uglier solution. So at the end, it all works out. It all works out. So that will be it. That will be it for today. Hopefully tomorrow I can do a bit earlier, so I don't have to really push my brain to the edge. All right, I'll see you guys tomorrow. Adios.